I'm really excited to be here. Thank you all for coordinating this and putting this event on. I've been to a number of the DevSecOps days in the past, and I always feel like I learned something out of it. So thank you for putting these on. I wanted to take this year and share something back and contribute some things back to this community. Share the practices that we've found work well for our clients that we support, both in the commercial and government side, and really talk through the subject of how you engineer resilient systems. So I'm really intending, both if you're a software developer, cybersecurity practitioner, maybe you're more part of the test and quality assurance disciplines, or maybe you're in the business management, program management side of things. I hope that there's something that you can take away from this. It's been touched on before, but we really operate in a very complex mesh of global supply chain in today's day and age, where everything is interconnected. And whether you're the large prime that fields systems to mission critical environments as a lead system integrator, or the mom and pop shop that develops tax accounting software for Ukrainian citizens, right? I think we all have a part to play. Everything's really interconnected, and you look at the whole, what CISA identifies as the 16 sort of sectors, critical infrastructure sectors, really accounts for, in the order of hundreds of $billions of market value. So I really intend this to reach a pretty broad audience here. I think there's a little bit something for everyone. So really get into that. I'm going to cover a number of subjects. Really, the point is to push forward and demonstrate the tactics that we've proven work out well in these types of environments, particularly critical infrastructure, specifically in the maritime domain, and put forward and show what our playbook looks like for building cyber resilient systems that could survive cyber-enabled events. Going to talk through both historical, look a little retrospective on things that have been discussed and identified about where the status quo has failed in this area of security engineering, review sort of current debates around security and where it fits in as far as an engineering process with things like quality, just development of capabilities themselves, identify a few gaps that we've found in the current discussion, what's sort of at the top of mind, what takes up the most airtime when you talk about DevSecOps best practices, where we would like to see the industry move forward together to cover those gaps. And then really, I hope that your takeaway from this is that security engineering can really be a core enabler of system performance. That's something that is really relevant in today's discussion. So a little bit about me to start, just briefly. I've got a background in computer engineering, boiler up, proud Boilermaker. But I got pulled into cybersecurity sort of by chance, and then I stuck around because I loved it so much. And throughout my whole career, both on the government side and now on my role on the commercial side, I've been involved very closely in the maritime domain. So commercial maritime transportation systems, as well as U.S. Navy vessels. To kind of break down the maritime domain, I want to set it up for what experience we have that is relevant for this discussion, and then tie that back to why that sort of matters and fits into the broader critical infrastructure picture. So you look at just one commercial shipping vessel. You have systems involved in power distribution. The ship's got to, it's not connected to the grid, right? The electric grid. It's got to get power from somewhere. It's got to generate power. It also has to transit the ocean. So it needs some way to navigate, right? You also have business IT systems on these platforms. You have propulsion systems. The ship's got to move. And then clean water. It's got to generate, it's got to distribute clean water for the lives that are on board to sustain life and make it across the sea. And so just on one platform in the maritime domain, you have pretty good representation from a number of other what we would call critical infrastructure sectors themselves, different types of critical infrastructure systems. You move over to the government side, on the military side, you have the same basic systems to support transiting the ocean and navigating the seas. But you also have other military systems, right? Things that are doing surveillance, reconnaissance, electronic warfare, radio frequency missions. And then mission operations, things like both shooting missiles and not getting shot by missiles. And that's just on something like a destroyer. You move to like a nuclear powered aircraft carrier, you add in air traffic control and nuclear reactors. So, you look across, it's one domain that we call the maritime domain, but you end up having representation from most other critical infrastructure systems. So I want to set the stage there because having experience in maritime, you end up having to get involved in a lot of these other complex, distinct types of systems. To go retrospective a little bit and look at why our current practices have led to failing to protect these types of critical systems across these different verticals. I'm going to start, I've got a couple examples, and I want to start with one from the National Institute of Standards and Technology. And I want to start with them because they are the source of the risk management framework that drives so much of cybersecurity implementation across federal systems. So they put out their own interagency report that it is reflective itself and identifies that most folks in applying the guidance that they have directed have done so without documenting traceability for things like these best practices back to why it's important for the business, why it's important for the mission. End up handling it like a compliance checklist, not considering how these things really work together functionally to protect the systems that are being built. And that it's a common failure. It happens whether we're talking about technical controls like they are in this case, or integrating tool chains, selecting new best of breed tools. If we're not thinking about how and why we're really implementing them, what their purpose is for the protecting the business and the mission and the critical systems, then their purpose gets lost and their value gets lost. My second example is one about 13 years ago. These bright minds in the field came together and put forward what they called rugged. Both rugged software, rugged organizations. They put together a manifesto and a supporting handbook and implementation guide. Highly recommend you check this out if you weren't aware of it. But they're saying a lot of the same things. You'll see commonalities, right? It's unclear how they even identify things that we all talk about as the best practices, but generally those don't get connected back to business goals. And that's the place where folks fail to take forward the ideas and the concepts into implementing them for value to their organizations. They don't coherently map them into security strategies for the organization and the business. They don't end up creating lasting value. And so, it was true in 2010. It's still true today. You have folks that don't, they're doing best practices and they claim they're doing all the best practices, but they don't step back and really ask or understand why they're doing these things. So we really need to move past that and really make sure that we're tying to mission requirements and mission objectives when we prioritize all the things that we know have to be done and are the best practices. So covering just the current debate, things that's really hot topic right now. It's whether security is a functional or non-functional requirement. To start with some definitions, if you're not in the DoD space and have been wrangling this question before, you probably don't even know what I mean by functional versus non-functional. It's a very DoD parlance. Functional is a unit of work. It's what the thing does. It's its sort of primary purpose for being. To use an example, in the form of a common requirement statement, the robot shall pick up a box, and the robot shall pick up a box and detect boxes. They shall pick up a box when they detect it. So two kinds of actions that a system has to do, right? Detection and then picking up some sort of movement of a mechanism. And then there's non-functional, which is more of the measure of how well that action happens, measure of its performance, how well it works. So equivalent example would be, box detection rate shall meet or exceed 95%, or the robot shall maintain 99% uptime. They're measurements of qualities of the thing that you've built. This matters because how you categorize a need really influences who does the job and in what way they do it. So it's fundamentally important to security engineering to define how you categorize this type of work. It'll either look like building or like testing, whether you categorize it as one way or another. That's why the debate is so important. So to break it down, some examples. Quality is the most common non-functional requirement. generalized into characteristics that we often call the ilities: reliability, maintainability, usability. They are relatively abstract. There's ways of measuring them, but you don't necessarily build these. They're not the functions, they are non-functional. Use that as baseline, but what about security? Where does security fit into this sort of group? Okay, cue all the debate. That's where folks get up in arms. Which way does it fall, right? Security is non-functional. I'm going to break this down. And when we talk about security and we define it, it's often along these types of factors: confidentiality, integrity, availability being the big three. You add in authenticity and non-repudiation. Availability also happens to get sometimes double counted as a quality factor on its own and a part of security. So then it's solved, right? Security, I don't build these things, I measure these things. These are definitely things to be assured, but this is why you often hear folks call security a concern, not a feature, because these things are concerns, they're measures, they're things to be assured. But that's not the end of the story, right? Security is also functional. If I look at what does it mean to build a secure system, what are the things that I need to build to make it secure? It's things like cryptography, encryption, managing secrets, things we hear again and again, right? Mutual authentication, logging, auditing, intrusion prevention, the list goes on and on. I think the only thing that a developer would be naturally inclined to do without being told about is probably logging, right? They have an inclination to log for debugging, troubleshooting, right? Live runtime monitoring. The rest, they don't just, my point here is these things don't just materialize. Somebody has to build them, and you have to really consider the things to be built up front. You can't just measure them into existence. So clearly security has a big part of functional requirements as a part of it. So I think functional versus non-functional is a false choice. There's a little bit of both involved in security engineering. And because of this, security engineering is really the perfect opportunity for DevSecOps as an engineering field. And not as a third thing to be integrated, but as something that's got a little bit of capability and feature development and a little bit of test, risk management, and quality assurance to it. It's something that really combines both of those sides of engineering into one discipline. So if this is such a perfect place for DevSecOps, are we meeting that as a community, right? As a broad field, as contributors, as DevSecOps practitioners, are our current approaches really taking that to heart? And I want to look at what are the common best practices that we all acknowledge and we all talk about, I think, the most. It's probably so common I don't even need to break down the acronyms, right? We all have the acronyms sort of drilled into our brains by now. But what looks familiar and similar about each of these kind of, I just throw out the top practices. It's that they're all really testing, right? A lot of them are testing code, but they're not really building. You can say that there's response to them, so you're certainly having a response cycle where you're iteratively improving the measures that are output by these types of activities. But security engineering has to go beyond the testing, beyond the traditional assurance, and really get into the things I have to build. And if we don't get past that, we get into this trouble of reinforcing the common, the old stereotype of security people being the ones that walk around with the clipboards and they're coming in to do an audit and they're checking whether you meet the audit and pass their bar or not. Security has a place in actual engineering, which means there's actual things to be built for security. So what are the recommendations? How do we get past the status quo? How do we acknowledge the things to be improved, move forward to resiliency? And I think it all centers on first asking this core question. What are the functions that I need to engineer into my system to protect, detect, respond, and recover from cyber events? It's really getting at the why we do these best practices. It's for the function of protecting my system and make sure it's up when I need it to be up. Threat modeling is a great place to start here. And I'm throwing out best practices, but I want to throw them out in a way that I'm also answering why you do this. Threat modeling starts to break down what have I built? How is my system performing? What are the functions that it's doing? And how could those functions potentially be misused? What can an attacker do based on my current design? And now I can prioritize the capabilities to be added, the things to actually be engineered, that can defend my system against those things. It's not a blind adding of requirements. It's not a blind following of different practices. It's really putting it in a way that can yield the most value tangibly into my production system. To go back to NIST, their interagency report proceeds down here with actually putting forward, I think, a pretty good model. I think it's a little bit funny because they bury this really insightful model into something that is just titled as automation support for security controls assessment. And I've recommended that they elevate that out because I really think this model could stand on alone as an engineering practice. But you see things like they're calling out that the results of security programs actually be clear and measurable, clear in a way that they are well-defined, they have a well-defined outcome, and measurable, meaning I can actually test that that outcome has been succeeded. And then they're linked to the business and mission results. The outcome is relevant to my performance of my business and my mission. They break it down into a tiered approach, starting with attacks, and you should acknowledge the sort of common patterns in all these things. It's starting threat-oriented. What is the attack that could potentially be executed and conducted on my given system? What are the capabilities that I need to actually defend against that attack, breaking it into sub-capabilities, and then only then getting down to control items. Avoiding the nature of treating controls as just checklist items, and now making sure they're really tied back to functional capabilities and system defense. So that's really, step one of how do you start approaching design. Rugged goes on to call out things like hardening yourself through real world experience, which means I am actually running the tests against myself. Think chaos engineering, but with the adversarial twist to it. I'm trying to hack myself. I'm using the adversary's own tools. I'm bringing in hackers. I'm pairing them with developers. And I'm doing it in a way that is setting up this continuous cycle. I love this picture of builders and breakers working together to iteratively improve security over time. So I'm having these folks constantly work together to identify weaknesses and then refactor code to eliminate those risks and prepare my system for future threats. And then the national security strategy, recently released this year, right, ends up calling out the same things. We need security to be built in as things are developed and deployed. And resilience is not just an optional capability, it's something that really is and needs to be commercially viable as an element of these systems. It's something we all know to be true security practitioners have been saying this for a while. We know this to be true. It's more of a question of reframing. How do these requirements, these things that we know we have to do, really lead to a change in system performance and a change in business value? That's what has to happen. That's the important part. So how do we take all these ideas, all these recommendations, and in Fathom5, how do we operationalize them for both our clients in the systems that we engineer and for the clients we advise on how to engineer their own systems? We put together, this is our playbook, our cyber resiliency playbook. It's 3 phases. First 2 phases are meant to be very rapid. So you should be able to complete phase 1 and 2 in a matter of 3 to 6 months. Pretty short turnaround. And then phase 3 is indefinite duration. It's what you do from then on to iteratively improve vector towards resiliency. And we really take this idea of breaking and fixing from rugged and try to put it into orbit. So phase 1, release the CVEs. It's get the data out there. Like some folks have said before, first line of code, you can do these activities. You can, from the first thing you write, from the first package you include, you can scan it for known vulnerabilities. You can scan your container images and start doing things like DAST. You can generate SBOMs on the software you've written and start scanning those SBOMs for known vulnerabilities. So this is something that doesn't have to wait for any other maturation of the program. You can do this from the first line of code. But I purposely don't say try to fix all the CVEs, right? It's release the CVEs. It's start from a point where you've got the data at least available and you can start making some actual risk prioritized decisions on what to fix, but it's giving you the opportunity to fix. So then we apply sort of combinations of CVSS, EPSS, and SSVC, exploit predictability scoring system and stakeholder specific vulnerability categorization into actually triaging these in a way that we're actually prioritizing based on risk and based on threat. phase 2 is speed run minimum viable security. So we posit sort of an idea here that the top 20% of functional things to be engineered for security can end up actually buying down 80% of your attack surface. So this is like the basics. This is secure by design, by default. What CISA is talking about is things like using memory safe languages, changing those default passwords, right? Limiting those ports that are exposed, segmenting your network, validating inputs, things you can do from day one, along with vulnerability scanning that have pretty wide-reaching downstream impact on reducing your attack surface. And then we have to get compliant in the DoD space. You can't deliver anything into DoD production systems unless you pass compliance. It's something we don't get away from, but we do prioritize resiliency over compliance. So compliance is something we have to check off, but if you do it the right way and you're prioritizing resiliency and basic fundamental security practices, you wind up delivering compliance systems, even though you haven't put compliance as the number one thing on the pedestal. And we're also trying to balance developer needs here. Developers have their measure of success is working code in production. Our measure of success as security people is the lowest possible risk, right? So we try to balance that there is a way to move forward and deliver an MVP, a minimum viable product, that is also minimum viably secure. But again, rapid. The last thing we get into that we then iterate over infinity is malicious BDD till infinity. So we take the idea of behavior-driven development and we apply the malicious sort of adversarial attacker mindset to it. And we write behavior-driven development statements, behavior statements. They characterize what can an adversary do on what I've built? How could they misuse it? It's really threat modeling, just taken into a sort of system resiliency context. And then I conduct white box software penetration tests to actually show developers this is how your code can be misused, what we've built, versus just theorizing and telling you what can go wrong, and then prioritizing the things to actually be built, proving that those things actually worked to defend the possible attacks. I retest, I repeat, rinse and repeat, go through this cycle again and again to build and incrementally improve my resilience of my systems. So to cover, security really needs to connect back to key mission outcomes if we want it to yield lasting value. Engineering as an engineering practice, it's both functional and non-functional. DevSecOps culture is key. The more you can break and fix your own systems, the higher your system resiliency can become over time. And we really can demonstrate clear, measurable improvement in system performance based on investments. That's something I probably would have gotten laughed out of the room for saying was possible several years ago. And I'm glad we're at the point where we can have that discussion and take it seriously. And over for any questions. I know we started a little bit late, so a little short on time, but I've got an email here that you can reach me afterwards. Would really love to talk with you. Fathom5 is both an engineering shop and a consultancy arm. So if you have any interest in talking more, I'd love to hear more about your problems and speak with you. Thank you.
So Matt, great talk and throwing out there some ways to make your software a little bit more reliable with some added security checks. So the one key thing that kind of jumped out at me is you're saying 20% of your security issues kind of fix the top level 20% fix 80% of your problems. So I always thought that was probably a good starting point, but I didn't really think that are those like good statistics, or is there like, any studies done on that? Because that seems, like a really good way to fix a lot of problems.
Yeah, I think this is why I think CISA puts out the secure by design and secure by default is they identify some top things there. Everyone has to start somewhere. I think we all would agree there are things that you should do that are more impactful than others. You could analyze, there have been, studies done on past exploits, analyzing TTPs, the common TTPs, the most prevalent ones, and then mapping to things like MFA that can defeat sort of some of the most likely to occur initial access techniques, right? So that's why I think CISA put together that basic list. is here are the things that really, you should do these first, because these really, based on the things we see in past TTPs, these really can prevent most of these incidents that we see.
Yeah, and that's, going through some of the earlier talks where, people were running into things like, SQL injection. And I kind of like jumped out of my mind. I'm like, it's 2023. Are we still talking about SQL injection? And I think that's, a lot of kind of these common security practices. I don't know if they don't, get taught to, newer developers or folks that haven't been in the industry for a while. But it seems like it's just a common occurring thing that happens over and over again. And it's like, oh, well, if you just don't do a string concatenation with variables that you're going to query a database with, you're probably not going to have a problem. But then again, we see that, the last time I saw it was, probably about 4 years ago. And I'm like, oh, well, this is written in, like 2008. Legacy software gets thrown on your plate and you're like, well, here's the security problems, this needs to be fixed. And it seemed like, oh, well, that's a no-brainer, but we need to start moving past there. And that seems like, hey, that 20%, those are easy wins and you get a lot of security out of that.
I agree. I think part of it is education, like you say. I think another part of it is just there is so much data and so much guidance and hardening materials and best practices that security people, we often throw out everything and say, here's the 1,000 things, you figure it out, right? So
do it all.
Narrowing down and really saying, start here, we're going to walk you through it, do these things first, we'll move on to all the rest after you do those. It's about prioritization and context, I think.
Yeah, good advice.